Hello, everyone, and welcome to this masterclass session that is being held by 100Coach. I'll be your tutor for today, Vishak Gangasandra, and I'll very glad to be running the session for students. So the whole aim of this session is to really outline exactly what is required to get 20 out of 20 in the student experiment across all the different sciences. So I understand that a lot of students right now across Queensland are getting their student experiments. They're probably due for a lot of people over the next 2 or 3 weeks. So I thought it'd be very helpful as someone who's recently graduated from the system and who's formed this group of students, high achieving students from previous years, to provide this resource and this opportunity to students like yourself right now going through grade 12 to get a sense as to, one, what really makes a good student experiment, two, what you should include to make sure you tick all of the criteria so that you're not really losing marks for simple reasons and you get every single mark that you possibly can. And three, to help make this whole process a lot easier for you and to create a shareable resource that you can share to all of your friends and people within your classes. So I think that this is really what we're aiming to do here in today's session. So without further ado, I'll get started. And to start off today's session, I wanted to give you a little bit of an introduction as to myself, my background, and why you're hearing from me today. So a little bit about me. I graduated in 2020. So I was the very first cohort of ATAR graduates. I'm from a school on the Gold Coast, and I got an ATAR of 99.95. So I got full marks in all of my internal exams. And more than that, I was also awarded by QCEE as the #1 graduating student in my cohort. So in 2020, the QCEE awarded me, and I was very fortunate to be awarded as the #1 ATAR 99.95 in Queensland. And really after graduating from there, I thought that it would be a really great idea to give back some of the resources and some of the knowledge that I had got through grade 12 to get me to score so highly and provide that to students, which is why I host sessions like this. I do quite a few of these throughout the year. So really keep in touch with myself, keep in touch with 100Coach, which is like an organization full of people like myself and other high achieving students who just run these sessions throughout the year. Now, before I get started, just wanted to put this contact detail in the chat for everyone. So this is an email address. If you have any questions, and I do mean any questions at all about your student experiments or grade 12 or just any of your subjects, feel free to send an email here. There'll be either myself or somebody else upon the team who will be able to respond to the question. As long as like in the header, you say like, this is a question for 100Coach or a question for Queensland, then we should be able to respond to you. And we're more than happy to help guide some of your responses. Now, a little bit of a quick overview of this session, because there's quite a lot to cover in today's session. Before I go on to running through the exemplars, is I'll start off with today's session talking about how you master scientific writing, right? So just generally in the convention of science and science articles, how can you best maximize your words to ensure that, one, you're conveying every single bit of information that you need to convey in as few words as possible, and two, your assignments actually sound smart, because it's quite an underrated thing. But if your teachers or the people marking your assignments think your assignment sounds smart, they'll think it's worth a really high mark. And although it would be worth a really high mark, just by making your assignments sound smarter, it makes it a lot easier for teachers and markers to give you marks. So that's like the general overview for the first section, which is mastering scientific writing. The second session for today's masterclass is formatting the science student experiments, right? So across physics, chemistry, and biology, the whole structure of a science student experiment should be relatively similar. Obviously, you've got different content, and I'll be going through all the different subjects with exemplars, 20 out of 20 exemplars for all of the different subjects. But I think overall, the format is quite the same. So I'll run through exactly what sections you need, how you should format these sections, how many words should each section be to reach the word count, right? And then from there, go on to talk about what information you put inside each of these sections to really structure it to make it easier for teachers to mark. Because one thing that students often don't understand is that teachers, they spend a lot of time marking, right? Which means that for each individual student's assignment, they don't look into every single word that is written. Like they often just skim through a lot of text just to make sure that they can mark all 30 student assignments in their class on time, right? So what this means is that if you don't structure your assignment well, it's harder for the teacher to identify the places within your assignment that you've included information and harder for them to give you marks. So in the section where we're formatting the science student experiments and where I'll be going over how to best format the science student experiment, I'll cover how you can best lay out your assignment to make it as easy as possible for the teacher to give you marks. Then data manipulation and presentation. This is a very quick section showing you what a good graph looks like and giving you ideas, if you have graphs similar to this, how you should realistically format your graph to make it look really cool, and then also to convey information quite well. And then I'll go through exemplars for physics, chemistry, and biology. That's the session for today. Now, before I get started, I do want to give you all a little bit of time right now to scan this QR code. So 100Coach, that's an organization that was established by myself and a few of my friends over from Victoria. So they started this organization in Victoria and it's been expanded to Queensland. Now, what is 100Coach? It is a group of high achieving past students, so students who've scored ATAR of 99.95, got full marks in all of their internals and 100% in their subjects, who've really come together to give back to the community and offer sessions like this. And every single week we have sessions in physics, chemistry, biology, English, math methods, and specialist math, where we'll literally just have a tutor going through a bunch of practice questions. So practice questions from previous exams, and also never before seen practice questions. So what we've done, and at least what I've done for physics and chemistry, because I tutor those two subjects, is gone and spoken to people who actually write the external exams for QCEE, and then really tried to capture some of their comments and incorporate it in my sessions to help provide a bunch of practice questions, very, very succinct practice questions, but also a bunch of information, knowledge, and just informative presentations to teach students exactly all they need to know to get full marks for the subjects that they're doing, more specifically for the external exam. So every single week we run a session, and if you sign up through this QR code right now, all you have to do is literally just put in your name and your email address, much like you had to do for today's session. You'll get a free tutoring session from an ATAR 99.95 tutor. So I think it's a very, very good deal. We're just trying to give back to the community, and if you can scan this QR code, would be really, really great to have your details so we can help you how best we can. And we tailor these sessions to our students, right? So you come along to this session, you tell us exactly what you want, and we'll provide exactly that to make sure that we're not wasting your time. And we're providing you with the specialist knowledge that helped us get 100% in all of our exams very recently. So we have people who graduated from 2020, 2021. Some of the students that we tutored got an ATAR 99.95 in last year. So they've been able to keep in contact with us to help share some of their thoughts. So I'll just give you about 30 seconds if you're in the middle of scanning this QR code, and then I'll jump straight into the content for today. Okay, so hopefully you've had some time. I know that there's actually quite a few people in today's session who are already in my classes, so really, really great to see you there. And for all of the people who haven't joined the 100Coach yet, feel free to sign up and you'll get a free session with one of our tutors. So first section for today's masterclass is Mastering Scientific Writing. So I'll be teaching you just generally what I've learned going through grade 12 and even university. By the way, for all of you, I didn't introduce this earlier, but I am studying at UQ doing their double degree program in biotechnology and medicine. So had to do quite a few scientific articles in my time and scientific reports. So here is, from what I believe, the art of writing to get full marks in your student experiment. So what makes good scientific writing? Really, there's three main points that make good scientific writing. If you can incorporate these 3 points into your student experiment, it'll sound really, really smart. And the smarter it sounds, the more impressed your teacher will be at it, and the easier it'll be for them to give you full marks. So the first point, very, very important, is write quantitatively for your results, right? So what do I mean by writing quantitatively for results? Well, if you get results, and for all of your science experiments, student experiments, you should be getting results. When you talk about them in text, because you have to talk about them in text, very quantitatively mention the results. So state very specifically, as the X variable increased from this to this value, the Y variable increased from here to here. Then more specifically, talk about aspects of the data. So talk about, okay, the uncertainty was this percent. Don't just state that there was a large uncertainty. Very quantitatively state what the results are. And you should do this throughout your text. So your rationale, research question, methods, and all of your introductory sections, this isn't applicable to there. But the moment you've introduced all of your figures, this piece of advice is applicable for everything after that. Okay, so when you're talking about your trends, patterns, relationships, very clearly state that not only was there a positive correlation of the trend, state very specifically, there was a positive correlation. This was the gradient, and give like the specific value of the gradient. And then state that as the value increased from this X value to this X value, the Y value increased from here to here. So be as quantitative as possible, because that will be the best for making your assignment sound very smart and very well reasoned and backed up by factual data. Okay, same when it comes to evaluation of your data. If you're talking about, say, uncertainties or errors, talk about the very specific percentage, right? Talk about the absolute values, talk about quantitative data in your results. Okay, and the same thing when you're relating your experimental results to your theoretical results, you should be aiming to quantify it as best as possible in text. So that's the first point. Second point, write concisely but diversify vocabulary, right? So what does this actually mean? I think at the core of it, this isn't an English assignment. You don't have to write in flowery language. You don't have to write multiple sentences to convey one specific point. Whatever your findings suggest or whatever you believe, write that as concisely as possible. I think teachers really like that. I don't think science teachers or markers for the science student experiment, especially for QCEE, who have to authorize the marks given by your teacher when it goes to confirmation, they don't really care about how beautifully you've written the text. They care more about how much text or how much content you've included in the text. Right? So you have to write concisely. If you realize that, say, for example, for the physics student experiment, if you realize that, say, for example, increasing the length of wire in a magnetic field increases the force that it experiences, very clearly write that. When you increase the length of wire in a magnetic field, we observed that the force experienced by that wire has increased by this amount when you increase the length by this amount, right? So that's what I mean by writing quantitatively and writing concisely, okay? And diversify vocabulary, right? This is just a general part about writing well, is diversifying your vocabulary. But what I mean here by diversifying vocabulary is using scientific terms. A lot of people, and especially people in grade 12 and even people after they graduate school, they write in very informal English. Like, this is a scientific piece of work. So the more formally you can write, the better it is. And it's good practice for later on in life, right? Diversify your vocabulary to very formal and scientific forms of writing. And that will help guide you in being able to write a very strong and very justified piece. Now, this is probably the main piece of advice, this final thing. And the reason why it's in all caps, capital letters, is because it's important. The most important thing on the slide. Use buzzwords. What do I mean by buzzwords? The marking criteria has very specific words that they like to use. Teachers need to mark your assignment based on that marking criteria. If you use those specific words in the marking criteria on your assignment, the teachers will be able to identify where you have very specifically addressed the criteria and give you the full marks for that criteria. Now, even if your data doesn't best address the criteria, even if when you're writing it, your results don't best address the criteria, if you use the buzzwords, your teachers are more likely to be able to believe that you have addressed the criteria. So it's the best way to optimize your marks. One, if you don't have the strongest data, but also two, if you do have good data, your best way to ensure that your teachers will give you marks. And if they don't, you can very clearly go back to them and state, okay, in the text, I have used these specific words here, here, and here. The marking criteria has these specific words needed. you need to give you the mark. So you force them to give you the mark in that case. So buzzwords are very important. Now, speaking of buzzwords, I'll go through the marking criteria to mention how you can use them. And then also very small things you need to be able to look for in marking criteria for being able to optimize your assignments. Okay, so this is the physics criteria sheet. Look, it's pretty much identical to the other sciences. The only difference is here it talks about gravity, motion, and electromagnetism. Okay, in chemistry, we'll talk about different topics, and biology, we'll talk about different topics, but everything else is literally the exact same wording. Like with the exception of the topics, they've kept the same words for all of the student experiments. So let's run through exactly what you need to include. So you have the first section, and it's really interesting, but the physics criteria sheet and all the criteria sheets for the student experiment have been structured in such a way that it's got introduction, data, evaluation, and conclusion, and then your communication skills. And I've taken snippets of the top mark sections for all of the different criteria sheet or the criteria points that you'll be marked against. So let's start with the introduction section. So informed application and understanding of the topics, to modify experimental methodologies demonstrated by a considered rationale for the experiment. So the best way to write your rationale, you don't have to use the word considered anywhere in your text, but the best way to write your rationale is using the funnel method, right? So a funnel, it starts off wide and it goes narrow. So start off wide, start off broad, talk about the big picture things about the field of study you're talking about. So with gravity, state that, okay, gravity exists. It exists between two objects with mass, right? And gravity has been theorized by Isaac Newton to follow this formula, which has these relationships, right? So the force of gravity is inversely squared proportional, or is proportional to 1 on r squared, right? So it's an inverse square relationship, or the force of gravity is directly proportional to mass. Okay, that's like the type of stuff you mentioned at the start. Then you go a little bit more narrow. So you like identify one specific aspect of that gravitational force. So you talk about, say, for example, orbital motion. This is physics context, but it applies for everything else, for all the other sciences. So you talk about orbital motion. You talk about, okay, you've got a body orbiting around another mass. It obviously has a centripetal acceleration, so a circular force, right? Which is acting in opposition to your gravitational force, okay? That's like going a little bit more narrow. And then at the very end, you go even more narrow to state, okay, you have your centripetal force of acceleration, you've got your gravitational force, very specific to one specific condition, right? So it could be on Earth, here with the variability of gravity on Earth, because gravity isn't constant everywhere on Earth. Like it depends on where you're standing, the gravitational value will change a little bit. So you get even more narrow in terms of your context until you're to the point where you've pretty much set up your research question. And then you write your research question based off all of the introduction you've given. And then you talk about justified modifications to the methodology. So mention your initial methodology and then go into the justified modifications. Now, a question coming in the chat to me, direct message, is do you have to mention the original experiment in the rationale? You don't have to mention the original experiment in the rationale, but you do have to mention it somewhere in your assignment. So I personally wrote it straight after my rationale in the section talking about methodology and modifications, but you don't have to go too much into depth, right? In the sense that you just have to say the original experiment tested this variable against this variable. We thought that this was negligible of this additional variable that we haven't even considered. So that's why we modified the experiment so we actually considered this additional variable. That's like what you would write. You don't actually have to go too much into depth. You don't have to give all the apparatus and the specific methodology. You just state what you did originally and what you're changing and what variables you're introducing new. Okay. Then a specific and relevant research question, important, specific and relevant. When I go through exam class, you'll see it. Specific and relevant means you have to use as many numbers as possible to be as descriptive as possible. And I'll go through it in exam class, but you have to state, okay, if you have this variable, what is it measured in? What is it measured by? If you have this independent variable, what are you changing? How are you changing it? Okay. A methodology that enables the collection of sufficient relevant data. That is pretty straightforward. And consider management of risks and ethical and/or environmental issues. This section, I'm going to be honest, I've never actually seen a teacher read. They just want to make sure that you've included it. So include it, don't focus too much attention on it. Okay, unless your teacher tells you to. If your teacher tells you to do something, then do that something. But look, I've never seen a teacher really care about the risk management section. Now, next section, evaluation and body. So appropriate application of algorithms, visual and graphical representations of data about gravity and motion or electromagnetism, demonstrated by correct and relevant processing of data. So this is the most context specific. Physics, correct and relevant processing of data is different to chemistry and biology, but apply formulas, especially in physics and chemistry. They've given you formulas, they've taught you formulas in class, use those formulas to process your data. Next point, systematic and effective analysis of experimental evidence demonstrated by thorough identification of relevant trends, patterns, and relationships. Use these words. Use the words trends, patterns, relationships in your assignment. It'll make sure that teachers know to give you the marks for it. Literally use the words trends, patterns, relationships. And through an appropriate identification of the uncertainty and limitations of evidence, actually state what the uncertainty is, absolute uncertainty, percentage uncertainty, and then link that later to the limitations of evidence that led to it. Okay. An effective and efficient investigation of phenomena demonstrated by the collection of sufficient and relevant raw data. So this is pretty much, does the data you collect actually address the research question and the phenomena of the research question that you're hoping to express, right? Maybe have a point there talking about the validity of the claim. So this is really where you talk a little bit about the validity of your claim, right? To say that, okay, this is the data we got. This is how valid it is to the claim and the research question. Insightful interpretation of experimental evidence. So this is the final section about gravity and motion or electromagnetism, demonstrated by justified conclusions linked to the research question. So actually state what is the conclusion. So state how is your research question answered. Now there's a direct message question coming in the chat. Other words, trends, patterns, and relationships interchangeable with each other, or are they each different? They're interchangeable with each other. They're genuinely interchangeable with each other. Relationships, I feel, is more targeted towards gradients of lines, right? So if you have a straight line, relationship would be like your gradient, but transparent relationships, they're pretty much interchangeable. And then your critical evaluation of experimental processes demonstrated by discussion of the reliability and validity of the experimental process and improvements at extensions. Okay, pretty straightforward. And then obviously in the communication, effective communication. If you have any questions, feel free to send it to that email, but this is like the main points. Now, the format of a science student experiment, how to organize your masterpiece. This is the format that I would recommend. This is a format that got me 20 out of 20 and got most other students 20 out of 20. Take a screenshot of this. I won't stay on it too long because I do want to get through exemplars, but take a screenshot of this. Okay. In terms of word count, rationale, anywhere between 300, 400 words. Okay. Research question depends. Method, it depends. Keep it short, maybe like 100, 150 max. Risk assessment, like 50 words max. Don't spend more time on it. Raw data, this really shouldn't count towards your word count because it's just your raw data and sample calculations, which shouldn't count towards your word count. Okay. And yes, someone asked me a question. The recording of this will be available. Graphical representations of data is the next section. Okay. Again, this is just showcasing the trend line, shouldn't count towards your word count. Analysis of trends, patterns, and relationships. This should probably be about 300 words, right? Talking about the specific trends, patterns, relationships, and your gradients. Okay. And you have your interpretation of evidence. This should be about 400, 500 words, right? This should actually be a good chunk of your actual experiment because the interpretation of evidence essentially shows you, okay, this is the evidence that we got. This is specific data, but what does it actually mean in relation to the research question, right? So sort of answering your research question through here and actually referring to the physics, chemistry, or biology content, like the actual phenomena and the content. Okay. Now, a question that's been asked, does process data count towards words? I think it's really dependent on what you write. Anything you write in text counts towards words. Anything that is like data in a table or figure legends ideally shouldn't count towards words. But every piece of information that is physically written in text, or it's like a text in a table, that counts. Everything that's like sample calculations or math or just numbers in a table, that shouldn't count. An evaluation of results. Be very quantitative, talk about the limitations and improvements and extensions, and then obviously conclusion and bibliography. Okay, next section, data manipulation and presentation. So this is just how to make data look really, really cool. So this is an example of a graph that I used in my physics assignment, okay, velocity squared against spring compression. Format your data like this. And the reason why is because it looks cool, it looks professional, and you've actually got a lot of data on here. So obviously you've just got a scatter plot, just a normal scatter plot. You've got your x-axis, y-axis, and you've got your minimum and maximum trend lines. How do you plot your minimum and maximum trend lines? Quite easy. You literally just plot a point here. For your minimum trend line, you plot a point at the top of the error bar at the start point, and at the bottom of the error bar at the finish point, and literally join that together by a linear line. For the maximum trend line, you plot a point at the bottom of the error bar of the first point and at the top of the error bar of the final point and join them together. And you can see your gradient progressively get larger because you're changing your gradient. So here, you're able to actually get uncertainty on your specific gradient, your graph looks cool, and your teacher is impressed because you've included a lot of deep analysis. Okay, now there's a question coming in the chat. Did you use Excel? Yes, I use Excel. Get really good at using Excel. Lots of tutorials online. Excel is like the gold standard for grade 12. Yeah, the gold standard for grade 12 and even a lot of uni work and professional work. So physics student exemplar, right? Let me share my screen to show you what a physics student exemplar is, right? Let me get that. Okay. So this is a physics student exemplar. This is how I've worded. I won't go too much in depth because I realize we're a little bit short on time. And someone's asked where this recording will be available. For those of you obviously watching the recording, you know exactly where that'll be. But this should be posted online to a YouTube channel, and I'll share the link on our social media channels and potentially to all of the students who registered for this session. But yeah, this is the physics exemplar, okay? Table of contents, you can see it looks exactly like this. What I did, so my research question, I put first. I would recommend you probably put your research question after the rationale. So what is the physical relationship that exists between the compression of a single spring, X, right? And thus initial velocity of a projectile? To be honest, I should have, and this is just me critically looking at, this was my assignment, by the way. I should have used spring in meters and thus initial velocities in meters per second. So you should add very specific details in your research question. And the range of a projectile in meters of constant mass launched horizontally by the spring from a constant height and a constant angle, assuming gravity remains constant at 9.8 meters per second squared. So I know it's very pedantic, but including as many details as possible is really, really good. In your rationale, again, start off with big picture aims, right? Start off with some big picture theory. Here I talked about a guiding experiment, and then go in to talk a little bit about formula and phenomena, which will be able to guide your evaluation. Okay, talking through more things here, more formulas, more physics phenomena and other related content. I go through it, and then towards the very end, I say, it is theoretically observed that the initial velocity is directly proportional to the range of a given projectile. However, the exact relationship is unknown, but hypothesized to be linear, okay, with a proportionality constant of this. Aiming to support this hypothesis, this is what we did in the experiment. So this is how you should form a good rationale, right? This is all the content and phenomena and all of the formulas. This aspect is currently unknown. This is what we're aiming to do. Well, this is the hypothesis of what we believe it should be. And this is what we're going to do to actually address this hypothesis and actually solve this research question. Then original method looked very, very straightforward. And I put in an appendix as well, the rest of my method. Modifications, put this in a table. Put as many things as you can in a table that's reasonable, because it helps the teacher very quickly say, okay, this student has listed 6 separate things. That's very comprehensive. Tick, 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 tick. Okay. Then risk assessment, don't spend much time on this. Results. This is what a good results section would look like. Okay. Have cool tables, shade your tables just so it's easier to read. Outline outliers is another thing that teachers like. If you can identify outliers in your data, and then you can remove them from your data analysis. Okay, sample calculations, put a few sample calculations in there. This is what your raw data should look like. Analysis of evidence. So this is when you process your data using specific formulas regarding the content that you have, right? This is what my process data look like. And going through a bunch of other things, this is what my interpretation of evidence is. Evaluation of experimental results. So in my evaluation of experimental results, I outlined in 2 separate sections what the experimental faults were, so actually conducting the experiment, and in data processing, right? So we had to shoot a ball and measure the speed over time, what the data processing faults were. And again, in a list, it makes it very easy for teachers to mark. Improvements and extensions. Improvements and extensions, you can write in a paragraph, ask what your teacher likes, but in a list, I feel is easier for them to mark. Improvements, extensions, right? And then conclusion. Okay, and then I've got reference list. Aim to have quite a few references anywhere, but around 10 references is good, and then a bunch of appendices. So this is the physics experiment. Let's run through a chemistry experiment. Okay. So this is what a chemistry experiment looks like, the electrolysis of copper sulfate. Okay, so in the electrolysis of copper sulfate, you've got your rationale, you give specific chemistry formulas, and then going through theoretical formulas here. Okay, you've got your research question. Okay, in your research question, that's the research question that you're given. Again, very specific, 1 molar copper sulfate, increasing cell voltage from 2 to 10 volts. So be very specific how much you're increasing it by what range in 2-volt increments, increase the mass of copper grams, right? After running the cell for 2 minutes, okay? Modifications, they've written their modifications here in table format, very, very easy to give marks to. Risk mitigation, quite quick. Analysis, right? Here is their analysis. And then you have all of your sample calculations, your raw and processed data, and then always have linearized data. If you can, try to get data that is linear. That is like your gold standard. If you can draw a straight line and you can talk about your gradient, that's the easiest way to get full marks for that specific section. Okay. They've talked about the analysis of the figure. So what does the figure mean? Transparent relationships. And then also what do these transparent relationships mean in the wider context of chemistry? Okay, conclusion, bibliography, and so forth. So that's this section. And very, very quickly, I will go over a biology student exemplar. Okay, this is the biology student exemplar. So effect of soil pH and biodiversity of ecosystems. Again, rationale is there. Very well in-text reference. Put a few in-text references. The more you can put, the better it is. Okay, they've got a quick formula there. Not as relevant in biology, but still pretty relevant. You've got your research question, your original experiment, modifications in dot point form, your safety analysis, right? Your data, your raw data, then your sample calculations to process your data and actually your process data, and a linear line. Linear lines are really cool because you can talk about gradient, you can talk about percentage uncertainty, percentage error, and your accuracy and how valid the claim is. And that'll help you be able to optimize your assignment for full marks. Okay. And then you've got your statistical analysis that this student has done, which is really, really cool. There's no necessary need to do it, but it would be cool if you're able to. Okay. And then at the very end, you've got your limitations, improvements, and conclusion and extensions. Okay. So this is just the general principles of exemplars. Right? When it comes to writing a good exemplar, there's obviously many different ways that you can write one. Feel free to send any questions you have towards that email address, and we're more than happy to help you. But I think what would be best is if you are able to come along to some of our sessions that we have weekly, we will run through what makes good student exemplars, student experiment exemplars, and how to best tailor your assignment. So coming along to those sessions would really, really help. Okay. I've gone through all of these sessions, and I do understand that this session has come towards an end. But if you have any questions, and I do have another session that I have to get going to now, so I don't think we have much time for questions here in this session. But if you have any questions, send a message to that email address. So the email address for everyone who's watching this recording as well is hello@50coach.com.au. hello@50coach.com.au. Send an email there. We're more than happy to guide you along the process. But I think what would be really helpful for all of you is if you're able to scan this QR code, chuck in your details, and we'll be in contact as to how we can help best support you through giving you details of more sessions like this, or being able to help tutor you throughout the year. But thank you, everyone. I know this has been a very, very dense and compact session and gone through so much content, but I think that it was very valuable for a lot of students. If you have any further questions, you know exactly how to reach out to us. We're the team at 100Coach. We're here to give back to students all across Queensland. So thank you so much for joining us in today's session. If you have any questions, you know how to get in contact with us, and we look forward to seeing you in all of our future sessions. And if there's anything we can do to help, please let us know and we'll make it happen. Thank you, everyone.